Hello, trigonometry. These are the video notes for lesson 14, inverse trigonometric functions. And so I wanted to start this video with a brief review of what an inverse function is. You can see on this image we have f of x equals x squared plus 2, our quadratic function in blue. That's been shifted up 2. When you invert this function, the inverse operation is the square root of x. And so in red, you could see the square root of x, which is been reflected over this golden line, y equals x. This is what makes these functions inverses of each other. If you locate a point on the blue function, 1, 2, for example, you'll find the opposite point, 2, is this 1, 3? 1, 3, you'll find the opposite point, 3, 1, on the inverse function. So here's our inverses. Now you can see, and I chose this picture as our example, because you can see that the blue function passes a vertical line test, which makes it a function, but does not pass the horizontal line test. There are two outputs, or the same output that has two different inputs, which is why then when you get to the inverse, you have this piecewise function keeping a positive and a negative. But this red one isn't a function. So if you imagine when you're doing inverse functions, you have to have what's called an invertible function so that the inverse passes the vertical line test. Now let's take a look at some trig. As you can see, the sine function as is fails the horizontal line test at multiple points when it reaches the same height for a different value in the domain. When we're thinking about an inverse function, we want to think about it with a restricted domain or a limited window. If we pick 0, and let's just say we pick 0 to pi, you can see we're still going to fail the horizontal line test. If instead we pick negative pi halves to positive pi halves, we get one continuous chunk of function from -1 all the way to +1 that includes every possible value of sine without any repetition. So what we conclude off of that is that inverse sine is defined in quadrant 1, which is 0 to pi halves, and also defined in quadrant 4, which is negative pi halves to 0, and technically it's also 3 pi halves to 2 pi. Now when we do inverse sine in our calculators, we're either going to get a negative angle between 0 and 90 degrees, or a positive angle between 0 and 90 degrees, representing this restricted domain. Let's take a look at cosine. Cosine is a little bit easier to restrict. Just start at 0 and end at pi. In this portion of the graph, you're going to get every value of cosine from +1 to -1 seamlessly with no repeats. That means cosine is defined in quadrant 1 and quadrant 2. Last one is tangent, and tangent takes on very similar values to sine because tangent is sine divided by cosine. So tangent is also going to be defined in quadrant 1, sorry, not tangent, but inverse tangent, and quadrant 4. So let's take a look at a couple examples. The inverse sine of 1/2 is the angle in either quadrant 1 or quadrant 4 where the sine value is +1/2. Since it's positive, it should be in quadrant 1. If you type inverse sine in your calculator and you're in degree mode, you should get the answer in degrees, which is 30 degrees. Your answers can also be given in radians, which would be pi6. On number 2, you see a slightly different notation called arc. Arctan is the same as inverse tan, and so we're looking on our unit circle for a value where inverse tangent is equal to -1. Since it's negative, it can't be in quadrant 1. It has to be in quadrant 4, since inverse tangent is only defined in quadrants 1 and 4. So here, our answer is going to be -45 degrees, negative pi fourths, or 315 7 pi fourths. These are the same angle, coterminal, defined from 0 to 360. It depends on the limits on your function. Next, we have arc cosecant. So the first thing we need to do, we're mixing reciprocal functions with inverse functions, and we want to be very, very careful. So the first thing we're going to do is reciprocate. This is the same as arc sine, and then reciprocate your fraction. And then you should always rationalize your denominator. So I'm going to multiply numerator and denominator by radical 3, and that gives me arc sine of rad 3 over 2. Since it's positive, my answer should be in quadrant 1. What is the angle for which the sine value is rad 3 over 2? Your answer should be 60 degrees or pi thirds if the answer is in radians. Last question is a nested function. So just like with PEMDAS, you want to do your inner parentheses first, then your outer parentheses. Write it as inverse sine. Sine of 3 pi fourths is in quadrant 2, and that value is positive rad 2 over 2. And then the inverse sine of rad 2 over 2 now has to be in quadrant 1, because inverse functions are only defined in quad 1 and quad 4. We're going to get pi fourths. So the biggest mistake here with doing this is assuming that these will cancel and that you'll be left with 3 pi fourths. Well, 3 pi fourths is in quadrant 2, and an inverse sine function is only defined in Q1 or Q4. Includes the video notes for lesson 14, inverse trig functions.